Now, one place where we have moving charges is when we have current. So if I have current in a wire, and that wire is in a magnetic field, and that can actually produce a force on the wire. And if I look at the units QV, I end up with coulombs, meters per second, right? So if I switch the seconds and I get coulombs per second, now I've got current. And then multiply that by meters, so that's like current times length. So force is also equal to IL cross B. And so that's our next equation here. And you can see in next to example 3, this instance where we've got a magnetic field coming out of the page and this wire. If the current is going up in the wire, so IL, so the current is going up, magnetic field is out of the page, that produces a force to the, in this case, looking at the page, to the right, and so that pulls the wire to the right. If the current is going down, right, so down and then B is out of the page, that produces a force to the left if you're looking at the page. So for A, question A, example 3, the whole thing there, the magnetic field is going into the page now. And so if this current is to the right, so IL cross B, B is into the page, that produces an upward force on A, right? Whoops, here we go. Can you see that? For B, now this one's going this way, so B, the current's going that way, the current is into the page, so that produces a force, or the magnetic field is into the page, that produces a force downward. For C, the current is down, the magnetic field is into the page, so we curl into the page, that produces a force to the right. And for D, it's coming down, and the magnetic field is into the page, that produces a force perpendicular to the wire. Okay, so pointing at a 90-degree angle down away from the wire to the right.